Second part of the object-oriented tutorial. The previous tutorial we saw what is object-oriented design is about and the core principles of object-oriented design, which is encapsulation, inheritance, and polymorphism. In this session we will use an example code to illustrate how these work. The previous example had the account class as the class that is the base class from which the savings and the checking classes extend, and the account class encapsulates certain information such as the name and balance, and it has methods which allows us to perform operations on this attributes such as the deposit, withdraw, get balance, and get name. The savings class extended the account class, and it had the specific attribute interest rate, and then it had a deposit and withdraw, and same thing the checking side we had the insufficient funds, free, deposit, withdraw, and process checks. Now I'm going to switch over to Eclipse and show how this works with Java code. Actually, I've done some work already on this, so I'm going to walk you through these classes. The first class is the account class, which has the name and balance as the two attributes of this class account. So I've declared public abstract class account. The keyword abstract in Java means you cannot instantiate this class. This class purely exists for inheritance, for code reuse by the other classes that extends from this class or the derived classes. So there are two attributes, name and balance, like we saw in the diagram here, and it has methods to set and get the balance and the name, and then it also has a display information, and I have a method right now for depositing an amount, and I have defined this method as abstract, which means this class does not really implement the behavior of this method. It only has the method signature over here, and it has a constructor for accepting a string name and a balance as a double amount the number, and assigns it to this name and balance. The second class we saw from the example is this checking. It extends the account class, so it inherits all the information from the account class, such as the data and the attributes, data and the methods, and then the checking class has its own constructor which just simply calls the super. So this is actually the name, and this is the amount. So we can give proper name and amount. So, and then it has a deposit method which sets the new balance as the old balance plus the amount. Now the savings class um, extends the account class again, and then it has the name, and it has an amount. Again, it calls the super class amount. The word super basically calls a similar constructor on this base class with the same name and argument. So when I'm trying to call savings of we'll illustrate it with an example, but when the savings constructor with the name and amount is called, it calls a super class as similar constructor, which is this one right here. If you notice, I have implemented this method deposit over here. Let me quickly see what happens if I take this off. It comes up with the error message saying that the savings class or saving class must implement the inherited abstract method from account. So that means the compiler is asking me to implement the abstract method uh, in the derived class. So you must implement the abstract methods. That's the reason it's defined as abstract. So I actually have some change here from the saving checking class to just to illustrate the polymorphism behavior. So I'm setting the balance here as the new balance, and the amount that is sent plus 10% more, just for example. I know in real world this will not be the case. The bank will not be adding 10% every time you deposit an amount into savings. So, we are now going to add a new class that will make use of all this concept and have the main method. So new class, and add the main method. We will call it OOD app and click on finish. So if you notice right now, we can let's just first create a two account object. Account acct1 equals new checking account of, say, John as the name, and $100 double value as the amount. And I am getting a compilation error. There is no account at the end. It is checking is the name of the class. That's the problem. And then we will create another account, saving account with a different name. Oops, we will call it a real person name, Jane. And again, we got to assign it to a different variable. So we have created two accounts. Well, let's see what happens if I do account one dot. It gives me all this display information, get balance, get name, all these methods which are not really part of the checking account. If you notice that none of those methods or values are in here, but you still are able to access it because of the inheritance principle that the checking account is extending from the account class, and you get all the uh, attributes and methods from the base class that are not private. Actually, that's another thing to remember, but we will go over the access modifiers later. So next we may, let's do account dot deposit $100 here, and then we do account 2 dot deposit 100, and then we display the information account 1 dot display info and account 2 dot display info, and see what happens. So we created two accounts, one of type checking, one of type saving, and we're depositing the same amount in both the accounts, and we are calling the display info. Now I'm running this and see what comes out. Run as Java application, save this. There you go, you got the name John, balance 200, the second Jane has a balance of 210. So this method right here is an example of polymorphism. So we are calling the same method, and what we see as the same same type of object here, but in at runtime it calls a different deposit method based on what instance type it is. So that's an example of the polymorphism. So we right now went through the encapsulation principle, where the account class encapsulates name and balance and exposes it through the getters and setters, and then we went over the inheritance where you get all the uh, methods or attributes that are reachable from the base class, and then we saw the polymorphism principle using the deposit method, where the same exact object or the class instance, based on what's the actual object it is referring to, we'll call a different method. Well, thanks for watching. We'll look forward to more object oriented related classes in the future. Thank you.